into e-learning because I think that this question at FAO or WHO on GMO that hit some of your queries, and I've mentioned class 30th. I think I have to cancel. So which means that Friday will be our last lecture directly to, okay? I hope you all know, all right? Okay, now some of you have already asked, we've learned with are those genetically modified, some examples, and hopefully, now basically I repeat again based on this cartoon. Now last time, coal being produced, so plant, engineered. Looking at two very different species, maybe possible just transfer the genes from one plant, a tree called tomato. They actually did grow that. Root and top, top with problem is with this kind analog, hybridized. We don't know. So unless we can actually see some materials or some genes to show whether if it's genetically modified or genetically modified, basically have the genetic makeup we can either, which means that, or we can, so that it can pick up, so long as the genetic may consider that as genetically modified. Sometimes when we talk about genetics, organisms, because this is the cause. So all are produced by the bio. Now assuming we are getting by a bacteria, genetically modified, that food be considered foods? What do you think? Yes, in many instances, if we were to talk about if that plant itself, and whatever food products that foods, the roots, they modified. Right? And later on, we're going to example of how mammalian cell technology can take modification for the production of drugs. I think it's vaccine, if I'm not. All that takes into consideration this genetically modified, produced, are being sourced. We describe gene technology, and genetic. Now, first they produce genetic. So for this topic, are based on genetically crops for the consumption of GM. Now the ways to have cheaper foods and benefit more people. Better crops, cheaper foods here, if you know of our agricultural crop, cuy, sometimes shooting up, and some so cheap. Sometimes cheap, but sometimes chili. Prices fluctuate based on demand and production. Demand is higher than production to be high. Now, what, in many instances, depend on the weather, land nutrient. So how to if we have trouble for us to have a plant, and therefore they can grow, be modified their genes. Now we have all these, a lot of nutrients are being drained from the soil, and that way. And in certain areas where they have infestation. But those pests or insects, sometimes they are seized every, maybe year, certain crops by the pests, because maybe grasshoppers, for certain beetles, but they in seasons. So those pests, we can to be resistant towards examples later. So we need to look at crops, healthier crops, and therefore we can have, and we can sell it at a cheap, more crops from the agriculture, more consumers. So the initial objective is protection. Prevention is insect resistance. Now, that is being produced by thuringiensis. Thuringiensis produce a toxin. It is used to resist, but incorporate that into modification of plant. One way is to actually into the plant. So is that the plant will have insects. So they are destroyed by the insects. Insects period, attack period. Farmers will be spraying. We do not want actually to be in contact with so much. Farmers are actually also money away because they. Now, if this model would have higher resistance to farmers, still need a lot of insecticides. Reduce insecticides, cost will be reduced, and will also have higher resistance on. So it's a we can actually reduce costs. GM crops have toxin because they have it, and they need the sites, which is also good. An example is the damage from left bacillus gene, no genes, and then the one to the extreme genes, two genes being. As you can see, if it were to have grown in pests and insects, so we are looking at a health resistance too, not just it can actually cause a lot of damage to food crops as well. Now this is what happens to leaves, and this is look like once it's attacked virus, so it has syndrome. And in micrographs of the virus under microscopy images. Once the leaves curl and all will be reduced, the tomato fruit production is actually not healthy. Happen when virus, but these plants that have been genetically recovering, as you can see, more healthier looking leaves, curl, yellowish. You can actually already see it again with the main crops. Now, these reasons for grow better, but some so genetically modified. Now, many of us times do tend lacking in vitamin A, carotene, the precursor for that we eat diet, we will get vitamin A. I'm sure all of you like go to the canteen at lunch. Be available. It's not too expensive. Ringgit, 80 cents. How much it is? Yeah, 1 ringgit. Maybe now a little bit more, but get it without sugar. I noticed without sugar still is. So next time, order sugar add separately, and then the sugar you can collect. Oh, that for granted. There are a lot of around the world. Vitamin A deficiency. There are many people that are facing vitamin B deficiency, nutrients, iodine deficiency, and things like that. We don't have to go through that too much. Don't have to go eat more, a few tubs more. Now, so one example here, variety rice, to enhance composition. So it actually is it beta carotene, the precursor for vitamin C. Later I'll show you. Turning orangey. So it's sake. For sake type of rice. But glutamine content is high for sake optimization. Modified the rice again, less glutamine, and they can have. So those are all healthier plant purposes. So oil seeds, cooking oil. In Malaysia, we can have a lot of countries, but you can choose sunflower oil, sunflower seed. You soybean oil that would come from the soil. You can have it from canola. So all these are actually being pressed. Now, seeds will have oil. So which one is better? It's fatty acid profile. Will it have essential fatty? Will the unsaturated? If it's unsaturated fatty, what is it? C18-2. What kind of are we looking at? Polyunsaturated, unsaturated fatty acids. Profile determine how good. Now, in order to have, obviously, we want better profile. Hey, those plants will be genetically seeds that they produce will have 10 of fatty acids that we. So that is one example. I want you to read on this. Now, whatever that I've uploaded on understand, make note to understand all that is very important too. I want you to read on 3 things. Beta carotene on enriched rice. I think you can just Google that and you will find that on the web. If not, you get it from certain books. Why do we need to decrease lyse glutamine for sake brewing? How do we actually look at fatty acid profiles? What fatty acid profiles that are beneficial for all these canola and soy oils, all right? Now, the beta-carotene rice is also known as golden rice because of its color, already looking a bit goldenish, orangey. As you can see from the, I have a website here, you can have a look at that for your homework. So this is normal rice. This is the one that has been enhanced in beta-carotene. So the stronger the color, basically, the more beta-carotene. Now then, I found something interesting over the internet too. What is the color of carrot? Every one of us knows it's orange. But carrot wasn't orange last time, it was purple. And it was genetically modified to produce orange in color to match what is it? The color of the Dutch royal house. And during the modification, it enhances its beta-carotene content. So that somehow benefits us. And another example is, okay, before I go on with the xanthophyll thing. Now, why is it that we have to be very careful with all this genetic modification? Now, not all the time, whenever we genetically modify something, it comes out 100% as what we want. So in this instance, the golden rice was modified with one objective to increase beta-carotene. But during genetic modification, anytime when something is genetically modified, there will be something altered, something that we may not expect. And that is also why controversies arise. People are always worried. What if I eat the rice today and 20 years from now, something happens to me? We won't know. Actually, we won't know. Only time will tell. And if you were to run the experiment, how long you've got to wait? 20 years? 30 years? So unexpected things happen. And in this example, the unexpected thing is that another compound is also produced, and it is xanthophyll. Now, xanthophyll is the yellow pigment found in leaves. You know, when autumn comes, and then the tree leaves from green turns yellowish, orangey, brownish, and things like that. That is because of the increase in xanthophyll. So xanthophylls are also increased in this genetically modified golden rice. So sometimes for determination, if you were to just look at the color, it can be rather misleading. The enhancing color cannot be enhanced in beta-carotene content. It can also be because of the xanthophyll content. So it have to be constantly evaluated. Okay. Now, I will go on with a video before I let you read on this. or the contamination of genetically modified plants, material, crops, or organisms in our food system? Seriously, we won't know. Unless there's something done on labeling, and it's clearly labeled, well, this is genetically modified. You can choose to eat it or choose not to eat it. But unless we have a very strong labeling regulation, this is a bit hard to be implemented. Now, I want you to look at one of these article that I have. Fear of dumping back in 2007. Now, our rice farmers have actually called the government to actually stop negotiating the free trade agreement with the US. Now, one of this is, no, this was back in 2007. I don't know what's the current situation. It is because US is trying to introduce a LL601 rice here, and we call it a contaminated rice because it's genetically modified. So we don't know now if this is introduced in our country, what's going to happen? Because we would, unless, like I said, unless labeling is made clear, then we won't know whatever rice that we are eating, is it genetically modified or not. So one of the US Consumer Union consultants said that Malaysia is very vulnerable, to imports of GM contaminated rice, as there's no plan to destroy the crop. So Malaysia should resist and demand testing of any US rice for traits of LL601. But I don't know if that's really implemented, if we are really testing, or have we actually agreed to that, to import that. So US biotech companies have pressured Malaysia to drop Section 61 of our bill, which makes labeling of GM products mandatory. So as you can see, it's all about labeling. Now, in certain countries, labels are there. It's up to the consumer. You can choose whether you want GM food or not. Maybe GM food can be relatively cheaper. So certain consumers may still want the risk. But if it's not labeled, then we won't know. So, like some of the soybeans that we have, I believe many of the soybeans that we are buying are already genetically modified, but it's not on the label. So obviously we have that. Now, Clause 61 is one of the 58 contentious points that has stalled the US-Malaysia FTA talks. So we should actually look at what are the consequences. So another homework, read on this. Then back in also 2007, there is a bill table for biosafety, basically talking about should we have it labeled, what are the regulations, and so on. So I want you to read on that, and I want you to read more on this bill on biosafety, and what are the progress right now. And as of May 2007, our government will not back down from its position to make labeling of GMO products mandatory under the biosafety bill. So it has been reported that US biotech companies have been pressuring Malaysia to drop that bill, but up to then, it's said that it won't drop. I wonder if it's now, it's dropped. So check on that, all right? Now that is one aspect of the biosafety bill and how we react to it. But certain countries, especially the developed one, they have zero tolerance, like Denmark, zero tolerance. Completely no GM crops, GM materials, and all that. I think we are a little bit lenient. Okay. Now, there will be some concerns of genetically modified organisms or genetically modified crops. But before we look at the concerns, let's hear both sides of the story. What we saw in the video just now was one side of the story from Greenpeace. They don't want genetic modification, basically. But as we can see from the company Monsanto, they are hugely producing that, genetically modified crops, and they're trying to introduce that into the farmers and then next the market and the consumers. And of course, subsequently, the export market. But if we look at the other view of those people who are doing these genetically modified crops, they must have a reason wanting to do that. So what are their reasons? So let's hear what they have to say. know what's the consequence. Now, in my next lecture on Friday, we're going to talk about what are the consequences, some of the potential defects of genetically modified foods. But having said that, it may not affect everyone. So taking a chance for that, or to risk starvation and poverty. So it has got to be, I believe it has got to be in the hands of the consumer, not the hands of the producer or whoever has done the modified crop thingy. So we should be able to be given that chance, the choice to choose. But I do foresee that in very stricken poverty areas, they really do not have a choice. I read somewhere, I cannot remember which part was it, that poverty was so bad that they were eating clay biscuits. So basically biscuits made from clay, make it into small, round shape, flatten consequences of GMOs or GM crops. Now I want you to do your homework, go read on more on yourself, and read more on the biosafety bill and update me on Friday. All right? Any questions? No? No? To our gene after interacting with those genes. And those interactions are not going to take effect immediately. It's just like cancer. Cancer is not going to develop overnight. It's not like you eat some cancer-stimulating thing today and tomorrow you're going to develop cancer. It takes time. And it takes constant stimulating effects. So if you continuously to eat those and you're harboring all these genetically modified fragments of genes, seriously, no one knows what's going to happen. Yeah. So we are already eating a lot of genetically modified crops. Thank you. Any more questions? No more? On Friday, maybe?